Greetings, internet users. During stormy days, we can see flashes of light called lightning, followed by the awe-inspiring sound of thunder. These chilling flashes of light and sound can make us very nervous. Some people like them, while others are impressed, but not everyone knows what lightning is and why thunder occurs sometime after. It can even make your entire house shake. In the next few minutes, we will learn what lightning is and how it forms, and I will also provide instructions on how to protect ourselves from them. Lightning is one of the most spectacular and dangerous phenomena in nature. On the other hand, lightning is the illumination we can see during an electrical storm. Unlike lightning never touches the ground. Lightning is the result of an electrical discharge, and this brightness is always accompanied by thunder. Thunder is the sound companion of lightning and one of the best indicators of a lightning's power. As we will see, thunder is nothing more than a side effect of lightning that helps us know how far away the lightning is. Lightning is an electrostatic discharge that occurs between a cloud and the surface of the earth or between two clouds. These discharges happen inside a storm cloud where ice particles collide with each other. When it rains on the Earth's surface, natural evaporation carries water droplets upwards. Meanwhile, at a height of 2.5 to 3 kilometers, where the temperature is 15 to 20 degrees below zero, ice particles form and fall due to gravity. These ice particles collide with the water droplets rising from evaporation. These frictions and collisions result in the separation of electric charges and ionization, generating an electric field, which means forces exerted between charges until the moment when charge transfers occur, known as lightning. These charge transfers can happen between the cloud and the ground, between the ground and the cloud, within a cloud, between clouds, or from the cloud to the ionosphere. These collisions cause the electric charges to separate. The positive charges, protons, stay at the top of the cloud, while the negative charges, electrons, accumulate at the bottom. As opposite poles attract, all of this creates a positive charge that accumulates on the ground just below the cloud. The electric charge on the ground concentrates around any protruding object, such as a tree, a mountain, or a person. Sooner or later, the charge that emanates from these points connects with the bottom part of the cloud, resulting in the charge we call lightning. On average, a lightning bolt measures 1,500 meters, and the longest one ever recorded was in Oklahoma in 2007, stretching for 321 kilometers. A lightning bolt travels at an average speed of 440 kilometers per second, capable of reaching speeds of up to 1,400 kilometers per second. Along with lightning, there are two other phenomena that can make us very nervous: thunder. A lightning bolt heats the air around it immensely, instantly creating temperatures up to 30,000 degrees hotter than the surface of the sun. The hot air expands rapidly, but when it collides with cold air, it contracts. These drastic changes in expansion and contraction produce shockwaves that generate the typical and deafening sound of thunder. Scientists and people, in general, have given names to different types of lightning. The most commonly observed one is the streak lightning, which is simply the visible mark of the return stroke of the cloud-to-ground lightning. It is the most well-known and the second most common type. This type represents the greatest threat to life and property since it impacts the ground. This lightning occurs when negatively charged ions rise from the ground and meet positively charged ions in a cumulonimbus cloud. Cloud-to-cloud lightning can occur between cloud areas not in contact with the ground. When it happens between two separate clouds, it is called intercloud lightning. And when it occurs between areas of different electrical potential within a single cloud, it is called intracloud lightning. The electric discharge of lightning is accompanied by a light emission called a lightning flash, caused by the flow of electric current that ionizes air molecules, and by the sound of thunder, developed by the shockwave. As you have seen, for a lightning bolt to occur, we always need a potential difference, a voltage, just like the difference between the ends of a battery. The path of a lightning bolt always seeks to nullify the potential difference between the cloud and the ground, thus achieving equilibrium. Under normal conditions, air does not conduct electricity, and that's why it cannot produce lightning. However, as we increase the potential between two objects, we are storing energy that must be released in some way. The way it is released is by breaking the atoms that make up the air. This breakage is actually ionization, meaning this potential energy is responsible for removing an electron from the air atoms, allowing them to conduct electricity. This electrical breakdown of the air is the process responsible for the intense light we see when the electric charges have completed their path. We are left with ionized atoms that have to regain the electrons they lost. When they regain them, a quantum effect occurs, resulting in a characteristic glow in the spectrum of each gas. This means that not only does the air glow, but depending on the composition of the air, we would have lightning of one color or another. Lightning is so intense that it can produce streams of antimatter, as confirmed by NASA. Storms can emit flashes of gamma rays associated with lightning, in addition to high-energy electrons and positrons. Researchers believe that most of the gamma ray bursts, about 500 per day, produce beams of antimatter particles. The danger of lightning. All these processes, lights, and sound
sound should be enough to alert us to the dangers of lightning.
But in case it's not enough, here are some data. The potential difference between two clouds or between a cloud and the ground is sometimes greater than 1 billion volts, about 4 million times more than a home's electrical outlet. And when a lightning bolt strikes the ground, it reaches temperatures of 30,000 degrees Celsius, about 5 times hotter than the surface of the sun. So, as you now know, it's not at all advisable to be outdoors when there are lightning strikes, especially in open areas like the beach, the mountains, or a meadow.
How to protect yourself from lightning.
Lightning strikes tall objects, so if you're outdoors, never stand under a big or small tree, and avoid being close to power lines, as they are excellent conductors of electricity and can cause death or serious injuries. Seek shelter near or under a rocky structure,
like a cave or something similar.
If you are at home, avoid doors and windows. If you get caught outdoors during a storm, assume a crouched position. And most importantly, if you are fishing or swimming, get out of the water immediately.
How to know how far a storm is.
Normally, lightning and thunder occur simultaneously, but the time delayed between the lightning and the thunder, which is produced at the speed of sound, indicates how far the storm is.
The calculation is quite simple.
The first thing you need to do is observe and count the seconds that pass from the moment the lightning flashes until you hear the thunder. The difference in time between these two phenomena is due to the fact that sound in the air travels at a speed of 340 meters per second at an ambient temperature of 20 degrees Celsius. At 0 degrees Celsius, this speed varies to 331 meters per second. So, to calculate the approximate distance of the storm in kilometers, you just need to apply this mathematical formula.
For example, if there is a time interval of 12 seconds between the lightning and the thunder, the storm would be approximately 4 kilometers away.
If you hear the thunder and see the lightning at the same time, the storm is right above you. To determine if the storm is coming towards you or moving away, you simply have to perform the above calculation twice, with an interval of 1 or 2 minutes. If the first result indicates the distance to the storm is 4 kilometers, and after a second measurement, the result is smaller, for example, 3 kilometers, then the storm is coming towards you.
On the other hand, if the second result is larger, the storm is moving away.
These calculations are approximate since you would need to consider the atmospheric conditions in the area where the storm is occurring, as well as meteorological predictions to track its evolution.
Storms can be very interesting and surprising,
but always observe them from a safe place to avoid being caught in the storm.
If you enjoyed this video, give it a like and don't forget to subscribe. Share it on social media and leave your comments.